Okay, welcome to the lesson you've all been waiting for, the highlight of research methods, inferential testing, the statistics component of what we do as A-level psychologists. So before you start this lesson, do make sure that you have already listened to and progressed through the slides on descriptive statistics, so mean, mode, median, standard deviation and range, and that you're feeling really comfortable with that content before you start this lesson, because if otherwise you're going to find it hard. All right, so do go back if that's the case. Otherwise, welcome, and let's make a start. So we know that when we get data land on our desk, we must initially look at some descriptive statistics before we analyse the data. So as you know by now, we look at graphs, we look at distributions, we look at central tendency, we look at dispersion. And all being well, once our data seems sensible enough to analyse, we progress to the next step. And that next step is basically when we conduct inferential tests. This is a far more sophisticated approach to data analysis, way beyond just basic mean, modes and medians. And these kinds of tests allow us to make important decisions about differences in data and whether data is significant or not. And if that, depending on the result, the effect that we observe, we can then make decisions about implications in society, how applicable is the data and how useful is it in certain populations. So essentially what we're about to look at is a statistical and mathematical analysis approach to analysing data and testing for predictions. Now, there are three main steps that we follow and that we asked ourselves. And if we can get to grips with these three steps, I promise you, actually, any question on inferential testing, you're already going to be 3 steps ahead if you really understand this. When we look at data, and we're about to analyse data, we ask ourselves first, am I looking at a difference or a relationship between two data sets? So the data I have in front of me, is it essentially experimental, where there are groups, and therefore am I looking at differences between groups or conditions, or am I looking at a relationship between variables? Am I looking for essentially correlation? Is it correlational data? So once you know which one of those it is, you then ask yourself the next question. What is my level of measurement? Now what that means is how has your data been collected? And we're going to go through these steps in a lot more detail in a minute. So you ask yourself difference or relationship. Once you've decided that, you then ask yourself, what's my level of measurement? So how has my data been collected? And then you ask yourself, okay, what design has been used? And this is specifically relevant if an experimental design has been used. Essentially, you're asking yourself the question, has a repeated measures or has an independent groups design been used? Now, depending on the answers and the outcomes to all 3 of those questions, you progress to a very specific type of inferential test. Let's consider these 3 steps a bit more forensically. So, how do we know that we've got a difference and that we're interested in a difference in our data rather than a relationship? Well, the 2 biggest indicators to look for are where we have groups, conditions, where we're looking at different groups, different people or different variables, and maybe we're making comparisons between those groups. Now, more often than not, this is when we have an IV and a DV. So if there is an IV or a DV, so your IV being groups or conditions, and the DV is a variable that we measure across all of those groups and conditions, you should be pretty confident that you're looking at a difference. If there isn't an IV or a DV, and there don't seem to be many groups, this is when you're looking at a relationship or an association. And often this is when you have covariables. And we can have 2 different covariables, and we're looking at association or correlation between them. And we know a lot about correlations. So when we have 2 continuous variables and we're looking at correlating them, we know we've got a relationship on our hands. Now let's consider level of measurement. So there are 3 types of levels of measurement that we might be looking at in psychology. We can look at nominal, ordinal, or interval ratio data. Let's consider each of these in turn. So maybe you're looking at nominal data. If you've got nominal data within your data set and how in terms of how you've collected it, it will be very apparent because you'll have separate categories in your data set. And for each of those categories, there will be a frequency. So imagine if I got all of you in my class to group yourself into tall, medium or short categories. And within each of those categories, I had the number of people that were classified themselves as tall, medium and short. So let's imagine I've got 7 people in the tall group, I've got 4 people in the medium group, and I've got 10 people in the short group. That is a brilliant example of nominal data. I've got categories, and within each category, I'm looking at frequency, how often something occurs in that category. Could be that you look at how many days in the week were rainy or sunny. So right through from Monday to Sunday, you've got frequencies for both rainy and sunny. And often this involves tally charts. Now, it's great and it's quick and it's easy, but I'm sure you've realised already, it's really uninformative because actually it doesn't tell us anything beyond just the basic frequency. So imagine in the tall, medium and short group, I said earlier that let's imagine there's 10 people in the short group. That number 10 doesn't tell me anything about how short or the differences between people in the short condition, or indeed the difference between those in the short and those in the medium. So arguably it's not very sophisticated, but we call this nominal data and it gives us the frequency in a certain category. Let's move on to the next level of measurement, and this is ordinal data. So ordinal data is essentially anything that is ranked in a certain order, but it also includes rating scales, so subjective questionnaire data as well. Let's consider one of those at a time so that we really get this. Let's start with ordered data or ranked data. Earlier when we were looking at nominal data, I said let's imagine we've got 3 groups, tall, medium and short, and each member, depending on their height, gets into one of those groups and we look at the frequency in each. Let's imagine an ordinal version of that, and instead I asked everyone in the class to just simply line up in order from the shortest to the tallest. And I gave everyone a position. So the person in first position is the tallest and the person in last position is the shortest, and everyone in between there had a ranked order. That would be a great example of ordinal data. Now it's certainly more informative than nominal, but it doesn't tell us about the distance between each member of each data point. So for example, if you decided to rank people in order that they won a race, you'd have someone in first, someone in second position, third, fourth and so on. So clearly ordinal data, but actually it doesn't tell us about the distance differences between those races. So there's still a weakness because it remains at simply ranked order. Let's go back to that earlier point of rating scales. We said that rating scales also count as ordinal data. Now the reason that subjective questionnaire-based rating scales sits in the ordinal level of measurement is simply because it's not strong enough to make it to the final level, inferential level of measurement, that I'll tell you about in a second. The final kind of interval ratio level of data level of measurement is a very sophisticated form, and unfortunately rating scales like how happy are you on a scale from 1 to 10 with someone saying 8 actually doesn't make it to that level of interval data because it's just a bit too unreliable. If 2 people both said that they scored 8 out of 10 on a happiness questionnaire, we have no way of scientists of knowing that that 8 is an identical experience, and therefore it's a bit unreliable, meaning that we unfortunately have to hold that kind of data back into an ordinal level of measurement. However, the most sophisticated level of measurement is our interval ratio data. We will, in your A-level psychology experience, you will 9 times out of 10 refer to this as interval data. It is our most accurate form of measurement, and the reason that it is because it's data measured in units of equal intervals. So essentially, data that's been measured on a standardised scale. So things like time, weight, temperature, distance, hours, volume, all those sorts of things, test scores, IQ test scores, anything that is clearly a very objective and standardised measure of unit. And so this is preferred. And actually part of the reason it's preferred in psychology is not only because it tells us the most about the data, but if we wanted to, we could easily convert interval data back to ordinal, back to nominal if we wanted to. However, the other way round is not true. If we've only got nominal data, it can never be ordinal or interval. And if we've only got ordinal data, it can never become interval. So the idea is that we have interval level data and then we convert it to nominal or ordinal should we wish to do so for whatever reason. So there you have it. The first two steps of trying to decide what kind of inferential test to do. Do I have a difference or relationship? And what kind of level of measurement data am I looking at here? What next? We have the final step that we have here is what design has been used. So am I looking at an independent group design or am I looking at a repeated measures design? Now for those that are switched on and listening, you'll realise that this question only applies if you have already identified that you're looking at a difference in your data. If you have already decided that you're looking at a relationship, then this step is actually void, it's not needed. So if you're looking at a difference, you know you've got an IV and a DV, all you need to do now is say, right, is it just a participant only experiencing one condition, so you've got independent groups, or is it a participant experiencing all conditions, repeated measures? And you decide which one of those you're going to go with. And at that point, you're ready to pick a test. You've been through all the hurdles to now know, right, which inferential test should I use? And just before I introduce you to those inferential tests, I'm just going to go back one slide to that level of measurement, because I know I sort of just very quickly whizzed past that and it's not actually in your books. So I just want to pause so that you can either take these notes or screenshot this. As I've already mentioned, when you're looking at level of measurement, you can change interval to ordinal or nominal, and you can change ordinal to not back to nominal. But as said, you can't change nominal to ordinal or interval. So the idea is that we try to aim for interval data if we can. This is an interesting question. What do you do if you've got two variables that are measured differently? So let's imagine you've got two covariables, covariable 1 and covariable 2. And let's imagine that one of them is measured on an interval scale and one of them is measured on an ordinal scale. Yeah, so perhaps let's go with temperature. So we measure temperature in Celsius, which would be interval because it's a standardized unit measurement. But let's also imagine that we also try to correlate that with levels of happiness that day that we measured on a scale from 1 to 10. That would be ordinal. Now that means we've got an ordinal variable and we've got an interval variable in the same study that we're trying to correlate. And the general rule of this is that you always work towards the least favoured level of measurement. So in this case, we can't upgrade the level of happiness to interval. So we downgrade, essentially, we kind of say, okay, we can't get one of the variables to interval, so we'll just have to work at an ordinal level of measurement. And we'll put this to the test as we do some practice questions together. So guys, already you've had a lot of information about how the decision-making process that we have to go through. I want everybody to pause at this moment and go back through those levels of measurement. One thing that's going to help you to really understand that is if you have a look in your book, there is a handout and it's titled Levels of Measurement, and it's got some pictures of some cakes and donuts and a few exercise, 3 different activities for you to try out to make sure that you've understood level of measurement correctly. Now is a brilliant time to stop and to give that a go. And then once you feel that you understand those level of measurements well, you can rejoin the second video, which will be the next step to select a test.